Right, let's go through. This is where a lot of people want to focus. I'm pretty sure around about the sort of mid-year, end-of-year time. We're going to go through some typical exam papers questions. I'm not going to do the theory where it says state this law, what is the law of that, etc., because I'm just assuming that is known. Because please remember, definitions, laws, and things like that, they're a given, they're going to be asked, and just make sure you know them. You know what, 2-3 marks, the way it goes, and you've got them in the bag, which is cool. Right, now let's just have a look at hopefully you've downloaded the question papers that we're going to go through, okay, the ones you want to focus on specifically, right? Let's have a look. The first is a little bit on matter and materials, okay? I've said, what is the valency, if any, are multivalent, then show both valencies or whatever. Okay, then we're going to say, what are the valencies of the following ions? Some are polyatomic, show the chemical symbol of that. Then give the chemical formula for the following chemical compounds, etc., etc. So really these are, let's say, the theory pieces, okay? And what I'm going to do is I'm just going to get to my bit so that we can get through it quickly. Okay, all right. 3. All right. So what we've got is these are the things that the first 2 questions, okay, are those that you've got to know. The valencies of some of them, and also especially the polyatomic ions, right? Yes, on the periodic table, of course, you can work out your valencies. Remember, column 1 plus 1, column 2 plus 3, then skip across to boron, which is then number 3, okay, and then carbon, which is a plus or a minus 4, nitrogen minus 3, oxygen minus 2, fluorine minus 1, helium, neon, argon 0. They are the noble gases. They're inert because they essentially have full outer shells, so they're not going to share electrons with anybody. Right, so let's have a look at the first lot. They've said if they're multivalent, show it. Right, so what have we got here? Let's have a look. We've got copper. Copper, the valency of copper is either plus 1, plus 2. You could have shown it as 1 or 2. Remember, that's how it's normally shown in an exam question. They'll say copper 2 sulfate or whatever, copper 1 sulfide or whatever it is, okay? They will give the Roman numeral, right? Calcium, basically, and very often my calcium and my copper look very similar. So let me just tidy that up. Copper like that, okay? Calcium, you would have looked across, and you can see it's in the second column on your periodic table, which means calcium is going to be sitting at plus 2. Argon, Ar. Argon is sitting at 0 because it's in the far side. It's the inert gas, is it not? So it is 0. Okay. Then we had nitrogen. Okay. Nitrogen minus 3. Okay. Some nitrogens also have a minus 5, but for our purposes, minus 3 is perfect. Okay. You just count across fluorine, oxygen, nitrogen, minus 1, minus 2, minus 3. Okay. Carbon, plus 4, minus 4. Okay. Remember, aluminium is going to be plus 3. There it is. It's in the boron column, which is number 1, 2. Skip over the chasm and get to boron number 3. Okay. Then we've got iodine is a minus 1. Mercury, and we've got there, it's a 1, 2. Okay. And iron, the last one, okay, is a 2 or a 3. Right? Those are the ones that unfortunately you got to learn by rote. Okay? That you can work them out obviously from the periodic table. Okay? As I said, always go back to the periodic table. That's the way to do it. The next one was a nitride. Okay? And that's going to be N minus 2. Remember, fluoride, oxide, nitride, carbide. Those are essentially the top ones, okay? Also, you can have a sulfide as well, okay? Phosphide, okay? Chloride, bromide, iodide, right? Those there are going to be their natural valency. In other words, -1 oxygen, sulfur, sulfide oxides, -2 nitride, phosphides, -3. Okay? That's going to be those columns there, all right? Sulfate, SO4 -2. How do I remember it? Copper sulfate. I always remember those two like that, okay? Sulfite is SO3 -2, okay? Dichromate, Cr2O -2. And a chromate ion, CrO4 -2, like that. Chromate, dichromate. Why is it called a dichromate? Simple, because here you've got 2, so that makes it a dichromate. All right? Carbon dioxide, 2 oxygens, CO2. Okay? Right. Let's have a look at the next one. And the next one we had there was chlorate, which is ClO3 minus. Permanganate, MnO4 minus. Okay? Phosphate is going to be, I was going to write over here, PO4 -3. Very important one. Ammonium, NH4 plus, as opposed to ammonia, which is NH3, no charge. Okay? Remember that one? That's NH3 with no charge on it, right? So, this was chloride, Cl minus, and oxide O -2. Okay? Those are pretty straightforward, right? The next one was where they said, all right, they want us to write down the chemical formulas for these, okay? And let me just have a look what it was that they asked for, okay? We've got calcium phosphate. Now, how do we go about these? You can see how critical it is to know the names, right? Calcium is a Ca and phosphate is a PO4. But we know PO4, okay? Calcium phosphate is PO4 is got a charge of -3. And we know calcium is +2. All right? So how do we balance these out? When they come together, all right, what do we say? We say, well, hold on, that's a +2, that's a -3. When they are together, CaPO4, we need to use the baby numbers at the bottom here, and we're going to put a bracket, to balance out the charge. We want the charge to be 0. So we've got to multiply, essentially, cross multiply. So we're going to say calcium, we're going to say times 3, and we're going to times that by 2. So if we've got 3 calciums, +2, +2, +2, you can see the total charge there is +6. PO4s, I've said we've got 2 of those, so the total charge is -3, is -6. And therefore you can see straight away that, just let me get my +6 and -6, we have balanced out the charge. So whenever we are putting together some compounds, we need to go through this process, all right? It's critical. You have to go through, you have to know these ions. I know I keep saying the same thing, but trust me, if you know your polyatomic ions, okay, and the valencies you can work out from the periodic table, you are more than halfway there for this kind of stuff, all right? So therefore I can say, right, what are my numbers, right? My numbers are then, there's going to be 3 of those and 2 of those, right? That's what we've got. That's what our thing's going to work out as, isn't it? Okay? Then the next one they said to us is, let's get it back onto a black over there. All right. The next one they said to us, I just want to make sure, they wanted us to do The iron 2 oxide. Now, let's have a look. Iron 2 oxide. Well, no, now we know that an oxide, okay, an oxide is going to be, is an O minus 2. And they've said iron 2, which means it's a plus 2. So they are going to combine perfectly happily to be FeO, correct? One oxygen and one iron can go together. Calcium and carbonate, Ca plus 2, CO3 minus 2, Ca, CO3. They get together. Okay, sulfuric acid. Okay, now yes, you do have to know these, right? Because sulfuric acid is an important acid that we have to know, and it is really H2SO4. It comes from the sulfur here, sulfuric acid, all right? H2SO4. Aluminium oxide, right, there's an interesting, aluminium and oxide. Aluminium we know is a plus 3, oxide we know is a minus 2. Once again, we're going to have to cross multiply. Let's go through it. So therefore, we're going to need to have Al plus 3, Al plus 3. Can you see the total charge there is plus 6, correct? That plus that gives me a 6. So I'm going to have an O minus 2, an O minus 2, and an O minus 2 to give me minus 6. So my final thing is going to be Al2O3. Okay? Calcium hydroxide. All right? What about calcium hydroxide? Well, Ca is plus 2. OH, that's the hydroxide, isn't it? Is a minus 1. So you've got Ca and OH, but you need 2 of those hydroxide ions to bring it in. Okay? Phosphor 5 oxide. Okay? So we go phosphor 5 oxide. Okay? And we get P2O5. Okay? Next one is lead fluoride, is Pb. Now, Pb, you need to know the valency of lead. Lead is, if you look it up, it's a plus 2. These are the ones like silver and gold. They sit in that transition area, and we don't know them offhand. Those are the ones that we got to know because you can't work it out from there, can you? Okay? So we say, okay, Pb is a plus 2, and fluoride is a minus 1. So you've got lead fluoride, okay, PbF. Do you know, for some reason, I always put an L next to fluoride. I always have. Okay, so there we've got that. Now let's have a look at the next one. The next one, they said, is potassium chlorate. Okay, potassium chlorate is going to be equal to KClO3 potassium chlorate. All right. Then they say, right. Okay. The next question is, and you can see all of this, big marks, but all you have to do is know the names and remember them, as well as the ions, right? That's why I say it's critical. Give the names of the following compounds, okay? K2O. Well, K2O, all right, what is it? It's potassium and oxygen together. Potassium oxide, right? Lithium and iodine, lithium iodide, okay? AlNO33, right? Well, let's have a look. Where does that AlNO33 come from, okay? Let's just have a look at this one. Take my screen up a little bit. We've got here AlNO3 with a 3 on the outside. Remember, NO3 was minus 1. I always remember it from nitric acid, HNO3, and I know H is plus 1, therefore NO3 must be minus 1. Al is plus 3, therefore we need 3 of those ions to attach to the aluminium to balance out the charges. Okay, Al plus 3. So that's where that 3 comes from over there. And what is it? Aluminium nitrate. Okay. The next one, sodium hydrogen carbonate or sodium bicarbonate. The next one, CCl4. Okay. Carbon and 4 chlorines, right? It actually looks like this, carbon, and it's got 4 chlorines that sit on it like that. You'll come across this guy when we do organic chemistry, and it is carbon 4 tetrachloride. We write it as carbon tetrachloride, like so. Carbon tetrachloride, okay? And then the next one is Mg3PO42. Wow. Mg3PO4 and a 2. Okay? Well, we can go through this if you like. PO4 was -3. So I've got 2 of them, which is -6. And Mg is +2 times 3 is +6, right? There we go. There's my balancing out. And it's magnesium phosphate, right? Magnesium phosphate. Okay, OF2. Anybody get that? OF2, okay, is oxygen difluoride. Okay, it is a trick one. It is oxygen. Let me just write that. Oxygen di, because of this 2 fluoride. Oxygen difluoride, okay? And then the last one, potassium permanganate, okay? Now, the next part of this is where we actually get into the table. This is question 5. They say, using the table below, show which state or phase each of the compounds will be in at the temperature shown. They've given various compounds from A to H, right? Those compounds from A to H they've given. Can you see they've given melting points, boiling point, and the temperature of the substance? Do you remember back to what I said? What we do is for each one, we draw a little graph, okay? And always reference it back to water. Because the water graph, remember, was this 0 degrees, 100 degrees Celsius, and over here it was ice, okay? In other words, solid, liquid, gas, remember? Those were the things that we had, the solid, the liquid, and the gas, okay? So now, then you take the substance that you've got and look at the temperature that it's at and put it on the graph. So if they tell us we've got substance A and it's got a melting point and a boiling point, we put those in. Those are the differences between liquid and gases, all right? So let us now, for example, say, let us take this one over here, okay? Let me just move my sticker down a little bit. Okay, let's just take this one over here now. Okay, they've given us melting point and a boiling point, 659. Whoa, this is some kind of substance, hey? So you put it in 659 degrees Celsius. This is going to be degrees C over here. This one would be time, remember? So what do we say? Melting point 659, boiling 2487. Okay, and that's all we really need to know, right? Okay, so there we go. We've constructed it. This is over here is the melting point. This is the boiling point. So up here it's a gas, a liquid, and a solid, correct? And then they tell us the substance temperature. It is at 2100. So we say it is up here. This is A. And we go and look and we say it is thus a It's a liquid at that temperature. So you just do a little sketch of each graph and stick it in where it is, right? Okay, let's just move up another one. Get it back to black. Right, the next one, and look at this. This is now, look what I'm going to do. Just draw a little graph, and I say, right, over here I am at a minus 259. So just draw my graph over here, minus 259 degrees Celsius. And my next point is up there, and it's going to be minus 253. Okay, so there we go. There is my gas, liquid, and my solid, okay? And they say we're at minus 240, all right? Minus 240, which means where are we? Okay, actually, we're up here, aren't we? Okay, so what am I? I am a gas over here. So B is a gas at minus 240. Just by the way, this one is hydrogen. All right. The previous one that we had over here was actually aluminium. Okay. So aluminium, okay, has got a melting point 659 and a boiling point of 2487. Quite a wide spread. Whereas if you look at hydrogen down over here, you can see hydrogen has got a very narrow spread. In fact, this difference here is only 6 degrees Celsius here. It's a very small window where you get liquid hydrogen. Okay. The next one, minus 39 and 357. All right. So draw a graph, minus 39. Okay, up there. And 357 degrees Celsius there. Can you see? Gas, liquid, solid. Okay, and this one is at, they tell us, is minus 60. So where are we? Okay, we are down here. Okay, and remember, I didn't finish it off. I was in a bit of a hurry. We can say over here, therefore, it's going to be a solid, and this is mercury. Okay, so it would be a solid. All right. Next one up, very simple one, but look at the temperature I've given. 0, 100. Okay, do our little steps, solid, liquid, gas, and I've said at 160. Okay, therefore it's a gas. This is water, okay, and that gas is superheated steam, okay. Then we can continue with the others, okay. The other ones, what you would do is you would do exactly the same, all right. Let's draw them just to complete them, all right. Minus 210 minus 196, minus 210 minus 196, okay, like so. Put my little step in there, okay, and then put where we are, red, let's say, is at minus 202, okay, minus 202, okay, so I am in here, aren't I? Minus 202, I know that's a gas, a solid, and a liquid. So over here, what do we have? We have it actually as a gas, liquid, and solid. Okay, a gas, a liquid, and a solid. So over here, it's a liquid, okay? And this one, by the way, is nitrogen, okay? And then just a few more, which are just to complete the sequence over here. Let's have a look. The next one is number F, which is minus 114 and 78. So you just do the same. Minus 114 and 78. All right. Complete the step there. And this is, yes, solid, liquid, and a gas. Okay, and where are we? We are solid, liquid, gas. We are at 85. So we are up here. So we are a gas. Okay. Next one up to the plate is going to be, okay, let's create another thingy. Next one up is going to be, look at this one. Now, here's an interesting one. They have said minus 78.5. This is the melting point and the boiling point, which means, what have we got? We've got something that does that, right? Solid. There's no liquid. Okay? This substance sublimes. Okay? Goes from solid to gas. Okay? That's dry ice, carbon dioxide or iodine. Okay? So in this sense here, we've got, and we're at 25, so we are up top there at 25, draw a line, so we are therefore a gas. But please note that if the boiling point is equal to the melting point, it means it goes straight from a solid to a gas. Right. Let's have a look at the next one. 2076 to 3927. I've taken these because they're very high numbers. 2076 to 3927. Okay, I mean, look at the things of this. That's a heck of a temperature, right? So this is where it becomes a gas, a liquid, and a solid down there. And we are at 2200, so we are slap bang in there. Okay, up there, which means we are a liquid. Okay, we are a liquid in this case. Okay. So that's what we do with these, right? We go through it and we identify which, using the water reference. Just keep in mind the water, okay? Here's my first step, is from solid to a liquid. That's step one. Step number 2 is from a liquid to a gas. So there's our 2 steps, right? You label the step, this is now in water, this is my melting point, right, where I'm going to move from one to the other. This is my boiling point. Okay, stick those in and put the 2 numbers and then see where you are on those scales. Okay, once again, excuse me, you can see that the critical element in all of this is you've got to know the names and the valencies specifically of polyatomic ions. The reason I say specifically is because for example, grade 11, 12, you're going to be getting the electrochemical or the electrochemistry series, which gives us a lot of the valencies of things like gold, platinum, etc., and lead on it. Okay, which is a huge help, right? But at this stage, we don't have those, so we've got to learn them and make sure you commit them to memory. And I can guarantee you will find that not only the understanding, but the speed of answering a chemistry problem goes up hugely by just knowing those ions, because it becomes second nature. You start knowing a carbonate, a sulfate, and you'll see that the normal ones that come up time and time and time again, generally speaking, no, dichlorates. They don't come up very often, right? The permanganates come up. The acids, hydrochloric, sulfuric, nitric, you've got to know those, okay? Phosphoric, H3PO4, you've got to know that one as well. Okay, in the next section, we're going to be looking at some of the atomic structures. Okay, we're going to go through and we've got some tables where we're going to go. That is going to be starting at question 6. Thanks, I'll see you in the next one. And hopefully we've covered that part quite well. Please go and learn those ions. Cheers, bye.